Hello AS Math, welcome back, exercise 2F. This time instead of intersection of lines, we're looking at intersection of curves. So for those of you last time who got creative with your lines and you're like, hey, I can fold it and do this, now's your time to shine. We have curves, okay? So quick review before we get started, and I want you, if you're at home, refer to your notes and find this stuff. But if you're here in class, we're going to think for a second. What's a discriminant? Like, what's the equation for it? What does it tell us? And then I want you to also tell me what the three cases for the discriminant are. So some of those three cases, like if it's greater than, less than, and like what those mean, okay? And go. All right, well, we're back in class. So the discriminant is your b squared minus 4ac. You get that from a quadratic equation where you have ax squared plus bx plus c. And you just fill in those coefficients. And here are the three cases, right? So your first case is when your discriminant's greater than 0. You have two real roots. That means your graph is basically going to cross at two x-intercepts, okay? The second case is one repeated root. So you get 3 and 3 again. So if you factored it, you get like x minus 3 and x minus 3. So you get 3 twice. And we'll kind of take a look at what that looks like graphically as well. There's definitely an x-intercept of 3. And then if we look at this last case, that's when our discriminant's less than 0. We have no real roots, meaning our graph will never actually touch or cross the x-intercept line. I said that wrong. It's just not going to touch or cross the x-axis. Okay. So using the discriminant, we're going to do two things. Our first thing is calculate where a line and a curve meet, which is more about substitution than anything. But the second one, finding values of k that satisfy intersection constraints. You'll see what I mean by that soon, but we are definitely going to be using the discriminant with it. All right, so let's look graphically real quick what the discriminant actually looks like, okay? So here on Desmos, I have 3 different graphs, and each of them have those 3 cases of discriminants. So this first one, this is when your discriminant is greater than 0, and you can see we have 2 distinct roots, right? We have -2 and 0. So our b squared minus 4ac is greater than 0. But if we have something like this, this is that case where you have that one repeated root. So actually, if you tried to factor this equation right here, you'd get x minus 4 and then x minus 4 again. You're getting that one repeated root of 4 twice. And it's just touching the line. It's just touching it. It's grazing it. Okay, it's not even crossing it. And then finally, here's our third case. This is when our discriminant is less than 0, never crosses the x-axis, and therefore we have no real solutions. Okay? So now let's bring that back to this lesson, and let's see how we can take those ideas and push them forward. And so if we're looking at the intersection of a line and a curve, again, we actually have 3 cases of that too. So now, like, for example, if I'm looking at Desmos again, and now I have, here's x plus 3, okay? Well, now we need to look at different cases of that and what's going on, okay? So now, let's do that. So our first case, this is when all points of intersection are distinct, they call them, meaning they definitely cross. My line is crossing this curve, and I even included the discriminant is greater than 0. But you're looking at this, you're like, they don't cross the x-axis. There's no solutions. We'll talk about that in a little bit more right at the end of this, okay? Right at the end of these 3 cases. So just for now, bear with me, okay? It's a little weird to wrap your head around, but it's not too bad, okay? So here's the second case. This is the second case. This is when the line is tangent to the curve at one or more points. What I mean by tangent is it touches, right? So if I'm thinking about like a circle, a tangent is a line. A tangent line is where it just like touches that circle right there, okay? And if you see right here, that line is just grazing it again. If we think back to our discriminant case, where it's equal to 0, again, we saw with that quadratic, it's just touching that x value, or that coordinate on the x-axis right there. It's just touching it, okay? So that is also when b squared minus 4ac is equal to 0. And then finally, of course, we have the last case where the line and the curve do not meet at all. Okay, we're getting something like this. They are never going to hang out, go to each other's houses, or gossip at all. They're just going to never talk to each other, and so our discriminant is less than 0. So you're thinking, why are you talking about the discriminant still? Let's think for a second. If we're, and again, I'm going to use Desmos to kind of help us out. Let's take this guy for example. If I treat the x-axis like a line, then those ideas that we just went over with those 3 cases about the curve and intersecting the line, aka the x-axis, then it starts to kind of build that connection a little bit further. Think about the x-axis as a line. Well, it's a line of x equals 0, right? You can't really see it because it's x equals 0, but, or I'm sorry, it's a horizontal line of y equals 0. That's my bad. Okay, so y equals 0. That's something we can actually graph, and there it is. Okay, finally got it. So if instead of y equals 0, instead of that being my line that we're looking at, now we're just saying, okay, what if it's y equals 2x plus 1 now? What if it's that? Well, now I kind of took my line, my original x-axis line, and now I've kind of rotated it around, and now it's looking like this. The orientation has switched. So don't worry, we're not going to be switching up orientations in class to solve problems. I'm using this to show you the connection between the discriminant and why we're talking about lines and curves and how that relates to the quadratics discriminant. The discriminant just tells us how many solutions we can get for a curve and a line meeting. And normally we were restricted to that line being at y equals 0, right on the x-axis. This time, we're not doing that anymore. Now our line can be anywhere, given an equation. So this idea of the discriminant still works out. So we'll come back to this. It'll help us with our k-value constraints, whatever those are. And then we'll talk about, first, actually finding coordinates where these guys are going to intersect. Okay, so let's do that first. So this is more of a typical problem that you would see on your homework, and this is scale 1. So we're going to find the coordinates of the 2 points where the line intersects the curve. Okay, and I sketched them real quick. And for this, I know we did it with lines. We did elimination and substitution. But for this, if we're doing lines and curves, always use substitution. Okay? So let's see what we can do with this guy. I'm going to take my line equation, and I'm actually going to rearrange it so y is by itself. So I get 2 plus 3x, like that. Well, now with that, I can substitute it in for this quadratic. So I'm getting 2 plus 3x equals 2x squared. And now, what I'm going to do is I'm actually going to rearrange it, move everything to one side. So I get 2x squared minus 3x minus 2 equals 0. And hey, look at that. We have a quadratic yet again. Okay? I'm going to use my slip and slide method. You can use the x method. But I'm going to slip this guy over here. So I get x squared minus 3x. This will be minus 4. And now I need my factors of negative 4 to add to negative 3. So let's see. We have 2 and 2. We also have 4 and 1. It looks like it's going to be 4 and 1. And now the 4 is going to be negative. The 1 is going to be positive. They multiply negative 4. They add, subtract to negative 3. And now, since I got those, I'm going to slip back under what I did in the beginning, my 2. Okay. This can reduce to x minus 2. This one can't reduce, so I slide the 2 back in front of the x, so I get 2x plus 1. Okay, which might be kind of hard to see. Okay, so that's what I got right there. So for continuing on, now we got to solve for x. We actually have to solve those. Let's move this over here. I got x minus 2 equals 0. I have 2x plus 1 equals 0. So x is going to equal 2, and it's also going to equal, this is negative 1, negative 1/2. So now with those, if I want to actually find the coordinates, right, I want to find the coordinates. I got my x coordinates, I got to plug those back in to either one of my equations. It really doesn't matter. Actually, that's not true. That's not true. I almost said that it didn't matter. It does matter. Please, please plug it back into your line equation. Okay? Plug it back into that guy. If you plug it back into this guy right here, you might get extraneous solutions, and that's not fun, okay? So put it back into your line equation. So I'm going to write that. Always substitute back into line equation. Whew. That would have saved you. That saves you guys a headache and me a headache. Okay, so let's do that. We'll throw them back in. So I get this is my original equation. So I'm going to substitute 2 in for it. I get y equals 8. So that means 2, 8 is one of my coordinates of where these meet. And then I put negative 1/2 in there. I get negative 3/2 plus 4/2. So that equals 1/2. So y equals 1/2. And x equals negative 1/2. Okay? Those are my 2 coordinates right there. Okay? And that's how you solve those, okay? So always substitute for lines and curves, and always substitute your answers back into your line equation, okay? Those are the 2 main takeaways. So now let's see it with something that's a little bit more out of our realm, something more out of our comfort zone. Alright, so if we're looking at this guy, it says find the value of k for which the line 2y equals x plus k forms a tangent to the curve y squared equals 2x. That's a key word right there, is tangent, and we'll see how that's going to come into play in a little bit. So again, like with our last problem, we got a quadratic out of this. So we're going to see how to use the discriminant to actually find the values of k, okay? Because it's not too bad once you know what to do. All right. So I'm going to take this guy and I'm going to rearrange it. I'm going to actually isolate the x. So this is going to be x equals, I move the k over, 2y minus k. And now I'm going to substitute that x in for this guy right here. All right. I'm going to continue on. All right. This is not 1c, this is a k. That's trying to be a k. It wants to be a k so bad. I can't wait. Maybe one day it'll be a k when it's older. So we distribute this. We get 4y minus 2k. Sweet. And then I need to actually move everything over. So I get y squared minus 4y plus 2k equals 0. And maybe you're used to using x's, but y's are just as good. Okay. This is still a quadratic form, right? We have it in the form. Now it's ay squared plus by plus c. Okay. So now we need to use a, b, and c to fill in our discriminant. Well, it says it wanted to be tangent, right? So that means that b squared minus 4ac, if it's going to be tangent, looking at our 3 cases, it's going to be equal to 0, right? So now let's go ahead and let's fill in what we know. So we know that b squared is negative 4 squared minus 4 times 1 times c was 2k, and that all equals 0. So now let's continue on. 16, and then minus, we get 8k equals 0, and look at that. 16 equals 8k, and k equals 2. So when k equals 2, that's when this line is actually tangent to the curve y squared equals 2x. Okay? So that's all that's asking for right there. If you would like to see it on Desmos real quick, we totally can. Get rid of all this crap. So what? We had y squared equals 2x. I wonder if that'll even... Yeah, it does. That's cool. There you go. It's a sideways parabola. And then for this guy, we have... let's see if I can do it like this. 2y equals x plus k. I can add a slider for k. Oh, that's sick. And there we go. I'm really nerding out right now. And we said k equals 2. That's when it's tangent. And look at that. It is. It's actually tangent right at that point. Look at that. I just love it when math works out. Anyway, those are your 2 skills today. So you're finding coordinates between an intersection of a curve and a line. And then you're also trying to find different values of k or c or whatever that constant is in order to satisfy the requirement of it being tangent or being distinct or having no solutions. Okay? This is Mr. Knight signing out. Let's get going on our homework.